Hello and welcome to this AutoPIPE training on analysis considerations for static loads. Here's a list of the available load cases in AutoPIPE. The static load cases are circled in green, and this shows how many of each type of load case you can have in each edition of AutoPIPE. Here are the differences between static and dynamic loads. Dynamic loading tends to increase the response of the structure beyond the response obtained if the same load is applied statically. A static load produces a system in equilibrium with reactions at supports equal to the sum of the applied loads. AutoPIPE offers two types of solutions for static loading. The difference between these two solutions is in the treatment of the supports and the soil and how they handle the nonlinear effects. Most supports in real life have gaps and might offer frictional resistance. These effects are considered to be nonlinear because the response of the support may change depending on the load. For example, a typical one-way restraint will prohibit pipe movement in the downward direction, whereas it offers no resistance to upward movement. Similarly, a support with a gap might not offer any resistance if the load is small. But if the load is large, the movement might be restricted by gap closure. Gaps and one-way restraints allow the designer to take advantage of the fact that these supports allow some or unrestricted thermal expansion or contraction. The behavior of frictional supports is considered nonlinear because of the complex interrelationships between support forces and the corresponding displacements. This frictional resistance may provide the additional restraining force needed to properly support the piping system without adding more supports. Soil yield also produces a nonlinear effect because the resistance of the soil changes with the intensity of the applied load. Once the load on the soil has passed its yield limit, it offers very little resistance. And you can refer to the buried piping training for more information on this topic. Nonlinear effects can also be analyzed with static analysis. All gaps are automatically closed and friction is set to 0 for dynamic analysis. Again, refer to the dynamic analysis and the nonlinear analysis training courses for more information. There are some assumptions that are considered by AutoPIPE when we run a static analysis. AutoPIPE uses a finite element analysis using the stiffness method, beam element theory, and it uses center line dimensions for the components. AutoPIPE assumes elastic response using small deformation theory first order only, so there's no change to the loading that occurs due to the deformation of the system. And if we use this simple supported beam, the first order theory considers the basic shear, moment, and deflection with respect to the undeformed structure. The second order theory would consider additional stresses in the structure, like the tension or compression in the top and bottom flanges with respect to the deformed structure. And again, AutoPIPE ignores that. The pipe remains linear, so there's no yielding of the pipe considered. The supports might act one way or both ways. Longitudinal bending deformations are only considered, so it ignores local stresses like the bending of the pipe wall and stress concentration at T's and bends. We use SIFs in pipe stress analysis to consider this behavior. There are 6 degrees of freedom per node, and the analysis is performed by solving a set of linear equations using the Gauss elimination method.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.